Hexadecimal, base 16, numbers are written using numeric digits 0 through 9, as well as the letters A through F to represent 10 through 15. Among the first 1,000 positive integers, there are n whose hexadecimal representation contains only numeric digits. What is the sum of the digits of n? To get at this, I want to look at the representations that don't contain numeric digits. So that's going to be the numbers 10, 11, 12, 13, 14, and 15 in base 16 are all not going to be numeric digits in base 16. And same is true for 26, 27. You divide these numbers by 16, and remainder is 10 here, remainder is 11 here, and remainder is 15 here. Anytime the remainder is a two-digit number, that's when the representation is not going to be numeric. And the same is true for 42, 43, 44. Basically multiply like 16 times 3 and then work backward, like the six numbers, six consecutive numbers that are less than integers that are less than 48 are going to be not numeric in base 16. And there are six in each of these kind of rows, and this will carry on until 986. Because 16 times 62 is 992. And then from that point on, from 992 to 1,000, the remainder, when the number is divided by 16, will be always less than 10. And so here again, when divided by 16, remainder is 10, remainder is 11, remainder is 12, and this remainder is remainder of 15. And so essentially one list, there's going to be another way in which we can find these non-numeric numbers, but this will get a good chunk of them. Basically, these are the numbers before 16 times 1, the six numbers before 16 times 1. These are the six numbers before 16 times 2. 16 times 3, these are the six numbers before that. And these are the six numbers before 16 times 62. And so the number of numbers that are here is going to be 6, because there are 6 in each of these rows, times 62. There are 62 rows here. So 6 times 62. And 6 times 62 is 372. So that's some of the base 16 representations that are not numeric. A way we can get other representations that won't be numeric will be if we look at 16 times 10 plus 0 is 160. And if you do that 160 divided by 16, we get 10, remainder is 0, and then from there, like we're left with this 10, and we know that 10, when we have this, it's going to be 0, remainder 10, which means that we're not going to have a numeric representation. So basically, any case where you have 16 times 10 plus 1, any case where we have 16 times 10 all the way to 16 times 10 plus 15, and you can test it. Like these will all not be numeric. Like we can see the same for 161. We're again going to multiply by 10, and we have a remainder 1 here. And we carry down the 10 here. Again, it's going to be 0, remainder 10. Like the remainder at this final step will always be 10 in all of these cases. And the same is going to be true for 16 times 11 plus 0, 16 times 11 plus 1, all the way down to 16 times 11 plus 15. So there are 16 numbers here that won't be numeric, and there are also 16 numbers here. And the same is going to be true. There are going to be 16 numbers for 16 times 12, and all it's plus 0, plus 1, plus 2. And same with 16 times 13, 16 times 14, 16 times 15. So 16, 16, 16. And I'm paraphrasing here, but it's 16 times 12 plus 0 plus 1 plus 2 plus 3 are all the 16 that are here. And so the total numbers that are here it's 16 times 6 numbers from this set that are not numeric, which is 96. And the same is going to be true for, let's then go to the next set of numbers. So 16 times 10, then we want to look at 16 times 26, because 26 divided by 16, that's when we start getting a remainder that is 10. So 16 times 26 plus 0, 16 times 26 plus 1, and so forth. And so same pattern of what we did here. They're going to be 16. And same with 16 times 27, 16 times 28, 16. Again, in total, we're going to have 16 times 6, which is 96. And keep doing this. Same process, 16 times 42, and 16 times 42 plus 0, 16 times 42 plus 1. We're going to get 16 from that. So again, 16 times 6, which is 96. And then this last one will be a bit more interesting. So we get all the 16 times 58 and 16 from that. 16 times 59, all those. 16 times 60, all those. 16 times 61, all those. But then when we start doing the 16 times 62, we have plus 0, 16 times 62 plus 1. It's not going to be 16 of those, because when we do 16 times 62 plus 8, that's equal to 1,000. And we're only considering numbers that are 1,000 or less. So there are actually 9 here that are going to work, and then there are 16 times 4 here. So 16 times 4, that's 64. So from this list, we have the 16 times 6, 16 times 6, 16 times 6, plus 16 times 4 plus 9. So all of those added together, we said 16 times 6 is 96. So it's 96 plus 96 plus 96 plus 16 times 4, which is 64, plus 9 is 361 from this list. And it would be easy to say that the number of non-numeric digits is just the number from the list we found up above, 372 plus 361, but it's not, because we double counted. Some numbers in this list here that we just found are also in this list. So now we just simply need to figure out, okay, which numbers did we double count? And we can pretty easily do that. So I'm going to look at the numbers in this kind of like second part that I did. We'll call this, here's part 2. And this is part 1. Looking at the numbers in part 2, we double counted 16 times 10 plus 0. Or sorry, 16 times 10 plus 10. Basically, we double counted all numbers from this list where it's 16 times blank plus 10 plus 11 plus 12 all the way to, and you can go back to part 1 and see that these are the numbers that were also in that part 1, but they're 6 from here. We also double counted 16 times 11 plus 0, and all the way to 16 times 11 plus 10, 16 times 11 plus 15. And we did this all the way through to yeah, it's basically all like from this first part for each of these, 16 times 10, 16 times 11, 16 times 12, for that first little sector, the number that we overcounted is going to be 6 in each, and there are 6 groupings of those. And same for the other sector, looking at 16 times 26 plus 10, 16 times 26 plus 11, and so forth, all the way to 16 times 31 plus 15. The numbers that we double counted there are 6 times 6. And doing that for all of these. 16 times started with 42 there. Down to 16 times 47 plus 15. Again, they're 6 times 6. So 6 times 6, 6 times 6, 6 times 6. And then considering back to the 16 times 58 plus 10, all the way down to the 16 times 61 plus 15. And then this is the last number that we would have double counted. And so from this, there are 6 times 4 that we would have double counted. And so basically the number that we double counted is 6 times 6. This is 36. So basically 36 times 3. So the number that was double counted is 36 times 3 plus 24, which is 132. So basically, the number of non-numeric digits is the numbers from part 1 and part 2, 361 plus 372 minus 132 is 601. So this is the number of non-numeric. So therefore, the number of numeric, since we're dealing with just 1,000 total possibilities, the number of numeric is going to be 1,000 minus 601, which is 399. And this problem is asking us, what is the sum of the digits of n? So basically, we found n. N is equal to 399. So the sum of those digits is 3 plus 9 plus 9, which is 21. So the answer is choice E.